So that means we can get deaths. We get the number of deaths. If we have the number of deaths, well, actually, what we're going to use instead, I think it's more natural to think of it this way. Just jump right to here. The population, age r, I'm sorry, the population in the region, in a given region, specific region, in time t, age greater than 10, is 1 minus the death rate times that same population, one period ago. Sorry, not the same population, it's the entire population ago. So if this is Alabama we're talking about, we're taking the population of Alabama over 10, we're multiplying it by the US mortality rate. So we're setting that equal to the US mortality rate times the population of Alabama 10 years prior. And we know that plus I minus X would give us, should equal that population that we observed. Now, by suddenly redefining our goals and saying we didn't really want to know both I and X, but we only want to know their sum, that is net migration, then we're home. And this is the very simple result. M, that is net migration, that's the difference, the number of people who come versus the number of people who go. Right? We don't know how many people really came or how many people really left. But on net, we can calculate it as the observed population over the age of 10 minus this, which is really an expected population. And this is an expected population abstracting from migration because it's just the survival rate times the previous population. So the number of people who would have survived, we would have expected to survive. Is that fair? Okay. Now, I want to do a specific calculation to make it really, really clear. The thing that I really want to clarify is that, well, what I just worked through was for population over 10. We really need to do this separately for each age category. Because each age category, we're going to observe a different mortality rate, therefore a different survival rate. So for each age and sex, we're going to do that same calculation. And right now, we're going to do one for males 20 to 29, who were 20 to 29 in 1850. And in the state of Virginia, there were 289,887 of them. I'm sorry, I got ahead of myself. It's the U.S. population total, 289,000 slaves, 20 to 20, male slaves 20 to 29 years old. In 1860, the number of enslaved males 30 to 39, right? 10 years older, 10 years later, 218,000. If we divide 218,976 by 289,887, we get 755.755. Right? And that's the proportion of 20 to 29-year-old male slaves who survived until 1860. That's the survival rate, yes?
Is that the survival rate that's supposed to be for those on the table that you gave us?
That is supposed to be exactly that.
Okay.
So why is it different?
Yeah, because we were confused if we were supposed to come up with our own survival rate and do the calculations ourselves, or if that's just explaining how you got it.
This is just explaining how I got them. And I gave you the survival rates as well. You're welcome to calculate them again, but it isn't required. And you had an important question on this. Yes? And that was?
I was wondering why it's over 1.0.3.
Why is the male survival rate for 0 to 4-year-olds, 10 to 14-year-olds 1.043? Can that happen? Yeah, you have an answer? I might have. Oh, wow. I don't recall explaining that way, but I think it's a reasonable explanation. It's clearly a mistake. People don't count slave babies very carefully, and they're not terribly sure of when they're 4 years old and when they're 5 years old. But I mean, this is easily explained by they just misplaced one or two, or about 4% of them. They just forgot to count them, but they turned up when they were 10, 14-year-olds are harder to miss. So I mean, it should again give us a little bit of pause. All data is imperfect. Remember, this is 1850s, 1850s and 1860s. There were some incentives to get these counts right, but it's possible to get them wrong. Yes. No, you should use these numbers. These are perfectly good numbers because they make the populations add up right. It won't. This will not affect. This is not going to affect your results any. But it's remind us that data is always a little bit shaky. Okay, so we now have a survival rate. We know the probability of 20 to 29-year-old male slaves in 1850 surviving to see their 30 to 39th birthday in 1860. Yes, your question? The number different here? It's voodoo. These were calculated using slightly fancier technique than this, where we allowed for continental drift and expansion of the universe. But no need to worry about it. But thanks for noticing. Okay, let's move on. So we know this survival rate. Whoops, that's not what I want to do. All right, and here's the calculation we're going to do. We take the male slaves who were 20 to 29 years of age in 1850 in Virginia. That's 36,974. We observed 26,000 of them in 1860. Right. So the expected population in 1860, however, is 36,974. That's the observed number in. Yeah. Okay. So 36,974. That's our observed number of slaves 20 to 29 in 1850. We multiply that by 0.759. That's the survival rate we saw on the previous slide. That gives us 27,915 expected slaves in 1860, age 30 to 39, and male in the state of Virginia. We compare that to the 26,858 that we actually saw. And I contend that the net migration, I minus X, is the difference between those numbers. 26,000 that we actually observed minus the 27,000 and something that we expect absent any migration. And so we have 1,057, negative 1,057, meaning that 1,057 slaves went missing or literally left the state of Virginia during that period. So you do that for all of the age and sex categories, and then you have a very good estimate of the total migration from each state, or from each state. I'm not asking you to do this for every single state, but do it for one of the new South states and one of the old South states. And for those numbers, I think you can say something about Bogle and Ingerman's 84%. Okay, now the questions. Yes?
So about
Let's see. Okay. Okay. So how do you get from here, from a bunch of numbers about the net migration, to a statement about plantation migration versus interstate sales? That's the question. Well, the numbers themselves aren't going to tell you the story. It's the distribution that's the key. You look at the percentage of different ages in the migration stream and compare those percentages to the populations, either where they're going or where they're coming from. Then you can make some kind of statement. Okay, do you see where that's going? What you want to do is compare the age distribution of the migrants to the age distribution of either the states they were leaving or the states they were going to, depending on whether you're looking at a new South or an old South state. Yes?
So we're just making assumptions, and it could be either or, but it has to be proven.
We are making assumptions. We are assuming that there is no international migration. We're assuming that the mortality rates are the same across the states. We're not trying to find. You don't have to find a number to compare to Bogle and Ingram's 84%. You can. I mean, if you want to try to do that, that's great. That's not essential. What I'm looking for is a graph that, or a table, or some display that you can look at and say, if slaves migrated as families or as plantations, it should look like either like this, how it looks, or it should look somehow different. Right? You don't need to fight with the 84%. For rhetorical purposes, you can substitute 84 for vast majority if you like. Right? So you can say you want a graph that would have an obvious look to it if slaves were migrating entirely as plantations. Right? That's the idea. You're going to compare these numbers in such a way that your graph just compares to a null hypothesis. A null hypothesis being, hey, they migrated as plantations. Right? And there's a trick to it. And there's definitely a trick. But that's why you've got a week to figure it out. I mean, there are more than one, certainly more than one way to do it as well. Other questions? Yes? Slaves that are over what? Over 80 years old? It's all kind of mushy at the end. You notice that there are slaves that report, I think, ages in the 120 range. Nonsense. Just as they're not too sure, just as they misplace infant slaves, they exaggerate the ages of older slaves. So I wouldn't distinguish too much between people over 50 or 60. I think you might lump all of them together. What do we have for survival rates here? How did I? Come on, there it is. Okay, so 40, 50. That's a reasonable cutoff. You can take everybody over 40 in 1850 compared to everybody over 50 in 1860. That'll be good enough. Okay, other questions? Yes? Bar graphs are great. Scattered dots are great too, but the lab report, the example lab report was a very different problem. So in that case, I think scattered plot was good. A bar graph would make a lot of sense in this. Doesn't have to be, but it's a graph that's going to show these proportions of populations next to each other. That's the idea. Spreadsheets are a little bit limited in what you can do graphically, but I think you can get bar graphs are a good choice. Yes. Other questions? All right, then. You have one more question? Yeah, it's a good thing to do 2 states, just so you can see, one state that's going to have lots of negative migration, one that's going to have positive migration. In your 200, well, you don't have to say. I mean, you can make your argument based on one of those states if you want to. But it's a little more robust to have something coming out, somewhere they came from, somewhere where they went to. But I think you can make the argument from either perspective too. Yes.
What do the slides have to do? What does that entail?
The slides should be the graphs. What I'd like from the whole group is, and again, this is all written out in the expectations document on the website. But and so if I say it wrong, it's what's written down that matters. I want a few slides, not a whole bunch of slides. As a group, you should prepare a couple of slides that you're ready to stand up and explain. Right? It should have a thesis statement. You should say, what you're trying to show this group, and then you should have 1 or 2 or 3, maybe 4, the right number of slides to make your point, and no more. And those slides can be tables, they can be graphs, but they should be numbers, not verbal arguments, not lots and lots of bullet points. They don't need to entirely stand on their own, but they should be clear enough that I can look at them and know what you're doing. Right? They don't need to be so detailed that a stranger who's never read Bogle and Ingram can figure out what you're talking about. But you should have a thesis statement and a couple of graphs. Then on your own, you write 272 words, and you refer to those graphs and tables. Okay? Great. Good luck, and see you Monday. And enjoy the spring weather.